So on to example number 3. So again, we're writing the equations of piecewise functions. This guy's a little light, but let's just call out a couple of things that are really important. We know we're going to have 3 functions. This is an arrow. This is an arrow. This is a solid circle and a solid circle. And then the other 2 are open circles. So we're going to write these 3 linear equations, right? So if we look at each one, I'm going to start on the left side. This line, it looks like it's a 1-to-1 slope. We can count it 1 to 1 to 1. And it keeps going if we were to extend it to -4. So its y-intercept is going to be -4. But remember, that extension is just something we're doing to find its y-intercept most simply. So we are going to write it in y equals mx plus b form again. And again, m is your slope, b is your y-intercept. And we just figure out the y-intercept is -4. So we know this is going to be a -4. We know there's going to be an x. And it is a negative line because it is decreasing from left to right. So because it is going down from left to right, it's going to have a -1 slope. So you can either put a -1 or just put a negative in front of your x. Because remember, the ones are assumed if they're not present. If we look at our second line, this one crosses through the y-axis, so no need to extend. It again is another negative line. So at this rate, we are going to write it in y equals mx plus b form again. So y equals and then x. And we know that our b is going to be a +4. And if we count our slope, it again is a 1-to-1 negative. So we know that's a -x plus 4. And then last but not least, we have our other line here, which looks like it is still a 1-to-1 slope. We do need to extend it to figure out what our y-intercept is. So that's going to be a -3. So this one is going to be y equals mx plus b. We're going to do y equals, it's a positive slope because from left to right, it is increasing. So it's going up. So it is a 1. So we're just going to leave it alone with an x. And then our y-intercept was a -3. So then we're going to write this in format of our piecewise functions. So we have y equals -x minus 4, y equals x minus 3, and y equals -x plus 4. And I wrote them out of order, but it's okay. So we know this is our purple line. This is our green line. And the one on the top is our pink line. Now we have to set up our domains. And remember, domains are x values only. So you are paying attention only to your x-axis. That's all you need to look at right now, those numbers alone. So if I'm looking at my pink equation, this is an open circle right here. So -2 is definitely our point. So we could have a -2 and an x for sure, because it's domain x values only. We have to decide if we want a greater than or less than. Since it's going to the left from -2, x values that are pertinent to this line are less than -2 as they're getting smaller. So all the x values are going to be less than -2. It is not equal to because that is an open circle. So when we get to our, let's go ahead and skip to our green line if I'm going left to right. So it starts at -2 and it goes to +4. And we know they're x values because these are many domains. -2, it's going to, the line is going to the right from -2. So that means the x values are getting bigger than -2. So x is going greater than -2. It is a solid circle, so that -2 also counts. So it's an equal to underneath that. So x is greater than or equal to -2 all the way up until 4. Now from 4, the x values are less. That's where it stops, less than 4. And if you write those numbers reading from left to right, it should always go in this sort of format if it has 2 numbers on either side. Okay? And then we're not going to put an equal to because that's an open circle. So last but not least, we have our function here. It starts at 4, and then it goes on to infinity. So from 4, all the x values are going to be greater than 4 because it's 5, 6, 7, 8, and so on, all the way to positive infinity. That is a solid circle, so we're going to put an equal to underneath it. So that's a 3-piece linear system of equation. Our next example, number 4, these are not all linears, and they are actually 4 pieces. So 1, 2, 3, 4, right? So then we are going to have 4 equations. This is linear. This is a dot, which we'll talk about in a minute. We have a quadratic here, which probably is going to be easiest to write in vertex form. So, sorry, this will be an x minus h squared plus k. And h and k, remember, is your vertex itself. So y equals x minus h. Linear is going to still be your y equals mx plus b. And this, if you remember from math 3, absolute value function. And that's just that guy, if it is a true parent function. It is a little over. So your transformations, just like your quadratic, is going to be x minus h plus k. And h and k are still your vertex, but this time it's a point instead of a circular turn like a quadratic, but it's still your vertex. H and k is always the vertex. So if we're going to look from left to right, if we look at our absolute value first, so this is our absolute value function. If you have a quadratic or an absolute value function, my suggestion is to find your vertex first. So negative 2, 4. Negative 2, 4. And then check your slope and just make sure it didn't change. So these are 1-to-1s. So the a value that would have been out here is still 1. So this just took a parent function absolute value and slid it 2 to the left and 4 up. So we know that that's going to be an absolute value. And then for it to go to the left, that means it went negative 2 spaces. But if I put a negative 2 with that minus, it's going to make it a plus. And then it went up 4. So that's our absolute value because it went up 4 and to the left 2. And if you remember, it's an x minus h. So minus minus is what makes that positive. Then looking at your quadratic, the way I always check their slope is I remember that it's a 1 and 3 to 1. So up 1 over 1, up 3 over 1. And that if that pattern is consistent, then I know it's a parent function quadratic. It just might have moved to the left or the right. But in this case, its vertex is 0, 0, so hk. So that means it's really literally just the x squared parent function of a quadratic. All right, and then our horizontal line, it's going to go through negative 3. So we know it's negative 3. And our dot goes through negative 2. So we're going to write it that way. So f of x. Now, for our domains, so we're setting them for x, because domains are always x. And I write x all the way down just to make sure I don't get crazy and excited or have to overthink the variable part. So looking at my absolute value, it looks like everything to the left, so smaller than 0, is part of this absolute value function. Everything from the left. So one way I've taught this before is if we were coloring in the domains. So everything that direction, because that's an arrow on the end, is absolute value. So from 0, all the values when x is less than 0 is part of this function. It's an open circle, so we're not going to put an equal to there. Then if you're looking at your quadratic, it starts, and again, you're really just focused on your x values, and then it stops right there at 2. So it's going to start at 0, and it's going to stop at 2. It's a solid circle at 0, and it goes to the right from there. So x is greater than and equal to 0. It stops at 2, and x is going, the values are going to the left, so that means x are going to be less than 2. But it's not an equal to because that's an open circle. Now for negative 3, this guy here, we'll come back to the dot because he's a special case. It looks like it has an arrow, so it's going to go on forever. It starts at 2. So again, remember, you're focusing on just on the x-axis. It starts at 2. And it goes forever to all the values larger than 2. So x is going to be greater than 2. And it's not equal to because that's an open circle. Now, our dot, so the output will be negative 2 for this function only when the input is 2. So when x equals 2, then y is going to equal negative 2. That's the only time. All right, so that's our next two examples. Great job, guys.